Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. Here is another video in Engineers in Progress, particularly on centroids of a triangle, and the principle there is about division of a line segment, which is just merely applying similar triangles of a right triangle. Now, for those who are uh, preparing for their engineering preparations, this is a video which will help you improve your thinking skills in the future. So the important concept here is simply applying similar triangles. So we have here a coordinate system and the plane. We have points P1 and P2 bounded by at 1, x sub 1, y1, and at 2, x sub 2, y sub 2. And let us say this is the point of division D, which is marked x sub D and y sub D. And the part from P1 to D is, let us say, R sub 1, its part, and from D to P sub 2 as R sub 2. So the ratio of the length of the line segment from P1 to D, which is R sub 1, and D to P2, which is R sub 2, is also simply the corresponding ratio of the parts of the right triangle. So if we draw the portion of the right triangle, by the way, the length from P1 to P2, the part there is also R. So these are the parts. So for the horizontal distance between P1 and D, it is simply right x coordinate, which is x sub D, minus left x coordinate, which is x sub 1. So this horizontal projection of P1D is xd minus x1. The horizontal projection of this P2 is x sub 2 minus x sub D. Likewise, we apply that same principle for the entire length P1 to P2. So we write x sub 2 minus left x sub 1. Then for the y component, so this vertical distance is y coordinate of the upper minus y coordinate of 1, the lower point y1. So yd minus y1. This distance projection of this P2 is y2 minus yd, and for the entire distance P1 to P2, it is y2 minus y1. So again, ratio of P1D to dP2 is the ratio of xd minus x1 and x sub 2 minus x sub d, and it is also equal to the ratio of the vertical component of distance yd minus y1 then over y2 minus yd. If you define an angle here in this many right similar triangles, let us say this is theta, you may define cosine theta, sine theta, and tangent theta in order to form this ratio. In other words, you don't need to memorize these formulas because it is merely an application of similar triangles. Again, the concept here is similar triangles, so you don't need to memorize these formulas. So that is if you are a good student. But if you're not really a student who have the potential and skills to be in engineering, then you keep on memorizing this without understanding it. So for those who are good engineering students, they will agree with me that you don't need to memorize these formulas. So likewise for the ratio P1D to P1P2, so it is equal to XD minus X1 over X2 minus X1, or YD minus Y1 over Y2 minus Y1. So I also close my eyes. I will not apply this. I'll just remember similar triangles. So centroid of a triangle, the derivation of this, you just refer to my derivation in Vitamath 21 in my other playlist. You look for the derivation of this, and for the centroid of a triangle, it's easy to remember. It's just 1/3 of quantity x1 plus x sub 2 plus x sub 3, or simply the average of the three x coordinates. So y sub c also is the average of the y coordinates, and you don't need to remember this. However, this is applicable only for triangles. If it is a quadrilateral, then you have to divide the quadrilateral into two triangles, and the centroid of each triangle can be found. And for the centroid of the entire quadrilateral, of course, you need to have advanced idea, that is by Varignon's theorem, and you should be able also to determine the area of a quadrilateral by area by coordinates, which is an advanced topic. But area of a triangle, you just enclose the triangle with a rectangle, then from there you can analyze the area of triangles, even for quadrilateral. But if you're still new, you're not familiar with Varignon's theorem, so we just focus our attention to the applications of locating the centroids of triangles. So y sub c is again 1/3 of quantity y1 plus y sub 2 plus y sub 3. Also, you don't need to familiar with this because it's easy to remember. It's just average. Then just remember the limitation of this formula. This is only for triangles. And if you want the derivation, refer to the derivation in Vitamath 21 in particular in my other playlist. So here is the first problem. Locate the centroid of the triangle having the vertices P1, 2, 3, P2, 3, negative 3, and P3, negative 1, negative 4. So this is simply merely applying the formula there. So the centroid x sub c is 1/3 of quantity 2 plus 3 plus negative 1, and that is 2 plus 3 plus negative 1, that's 4 over 3, 4/3. So likewise for the y coordinate of the centroid, 1/3 of quantity 3 plus negative 3 plus negative 4. So this is 0, so it is negative 4/3. For the next problem, so the centroid is at 4/3 comma negative 4/3. For the next problem, so all the problems here are all about centroids. The purpose of this so that you can remember the formula and the way how to locate centroids of triangles. The centroid of a triangle bounded by P1 negative 3 comma 5, P sub 2 1 comma y2, and P3 at x sub 3 comma 4 is at 1 comma 1. Find x sub 3 and y sub 2. So substituting, the x coordinate of the centroid is 1, so 1 is 1/3 of quantity negative 3 plus 1 plus x sub 3. So cross multiply, 3 equals negative 3 plus 1 plus x sub 3. So 3 plus 3 is 6, minus 1, 5. So x sub 3 is 5. So likewise, the y-coordinate of the centroid is 1. So 1 is 1/3 of quantity 5 plus y sub 2 plus 4. So cross multiply 3 equals 5 plus y sub 2 plus 4. So 3 minus 5 negative 2 minus 4 negative 6. So y sub 2 is negative 6. So finally, problem 20, locate the centroid of a triangle bounded by the vertices P1 negative 1 comma 4, P sub 2 negative 3 comma 2, and P sub 3 0 comma negative 3 by the fact that the centroid is located at a point on any median 2/3 of its length. So meaning let's draw the triangle first. So for this median 1, for example, this centroid or this midpoint between P2 and P3 is midpoint formula. Remember from the preceding videos that I have 1/2 of negative 3 plus 0 is negative 3/2. 1/2 of 2 plus negative 6 is negative 2. Negative 4 over 2 is negative 2. Again, 1/2 of quantity negative 3 plus 0 is negative 3/2, and 1/2 of 2 plus negative 6 is 1/2 of negative 4, so negative 2. So the centroid is here, denoted by x sub c, y sub c, and therefore the distance or the x distance would be negative 1 minus negative 3/2 is negative 1 minus negative 3/2 is positive 1/2. So the ratio of the length of line segment from here to centroid to the length of the median is 2/3. So that is, if we denote this x sub c, so x sub c minus negative 1 over negative 3/2 minus negative 1. So that's the ratio of the horizontal projection is equated to 2/3. So this is x sub c plus 1 over negative 1/2 equals 2/3. So x sub c plus 1, this is negative 1/2, then negative 1/2 times negative 2/3 is negative 1/3. Therefore x sub c is negative 1/3 minus 1, so negative 4/3. And if we check x sub c is 1/3 of negative 1 plus negative 3, negative 4 plus 0. So 1/3 of negative 1 plus negative 3, negative 4/3, which is this. So that is for checking purposes. Likewise for y sub c. So y sub c minus 4, vertical projection, ratio of vertical projection of the centroid to P1 as to negative 2 minus 4 is also 2/3. So that is y sub c minus 4 over negative 2 minus 4 is also 2/3. So y sub c minus 4, this is negative 6 times 2/3, which is negative 4. So cancel negative 4, y sub c is 0. And if we check, y sub c is 1/3 of 4 plus 2 plus negative 6. 4 plus 2 plus negative 6 is 0, and 1/3 of 0 is 0. So that's it for this video.